Hi everyone, thanks for tuning in. This is Nate, a Murf synthetic voice, talking to you from GradientN. In this video we'll show how to set the alpha filter for training graph data in NNetDesigner. Depending on the dataset, training can be relatively smooth or quite herky-jerky. We can use the training error alpha filter to smooth error calculation and display. We'll show how the alpha filter works using a net we built for the bodyfat.csv dataset. The bodyfat.csv dataset can be downloaded from Kaggle. The link is in the description box below. The dataset includes density, percent body fat, age, weight, height, and a number of other features that can be used to predict body mass. For our neural net, we'll use 5 input nodes, 2 hidden layers of 8 nodes each, and 2 output nodes. Our input nodes are connected to neck, age, weight, height, and chest. Our hidden nodes use an assortment of activation functions. We have sigmoid, relu, Shockley, arc cosine, Gaussian, and tanh. Our output nodes are connected to percent body fat and density. The net is trying to predict percent body fat and density given neck size, age, weight, height, and chest size. When we reduce the size of our window, we can see that we have 3 instances of NNetDesigner ready to train. We're going to set the alpha filter for each instance to a different value so we can see the effect on training graph output. We can set the training graph filter by selecting File and then Options. In the Options dialog box, we want to make sure we've selected the Default Values tab. The Default Values page allows us to customize a number of net settings, but today we're just going to work with the alpha filter. With the alpha filter, the larger the number, the more smoothing we get. If we set the alpha filter to 1, we get no filtering. For our first, or leftmost, NNetDesigner instance, we'll leave the alpha filter set at 10. For our middle net, we'll set the alpha filter at 100. And, for our rightmost net, we'll set the alpha filter at 1000. When we have our alpha filters set, we'll start training for each net. We'll reset our y-axis scales so we can better see the differences in training graph displays. After training a bit, we can see the difference in how each training graph is displaying its data. The net on the left, with the smallest alpha filter and the least filtering, is pretty spiky. We can kind of see the training performance is improving, but the jaggedness of the curve makes it difficult to know when training error has stabilized. For the middle net with the intermediate alpha filter, the training graph is smoother but still has some bumpiness. It is easier to see the trend in error value though. The training graph for the net on the right with the largest alpha filter and the most filtering is pretty smooth, and it's easy to see how training is progressing. It's not clear here, but we need to be careful in setting our alpha filter too large though, because too much filtering will slow training graph response and the graph can lag actual performance. How we set our alpha filter will depend on the dataset we use, the net we build, and our tolerance for noise in our reported training. When setting up our nets for training, we at GradientN like to set our alpha filter to be just large enough so we can see how training is progressing, but not so large that actual and reported error considerably deviate. Thanks for watching, we'll see you next time.